Welcome to my project bazaar.com. Let we discuss about the process fuzzy based face reduction algorithm using color models. This project is proposed for multi-human face automatically detection. The more no person face was detected based on the color segmentation process. The whole process application of a color based segmentation method has the advantage of developed model in HSP, UCRGB and RGB color spaces. The above methods are follow the process by the matched filter and template matching system. This process methods are used to detect the multiple faces in an image. In this process we have to been several studies and different approaches proposed on skin color modeling and recognition. The goal of skin color detection is to build a decision rule that will discriminate between the skin and non-skin pixels based on color components. In order to obtain adequate distinction between skin and non-skin regions, color transformation effectively separating the luminance from chrominance is needed. The skin detection techniques usually use color components in the color spaces such as HSP, UCSP and RGB format. The normalized formats studied and transformation in the spaces are performed. This is the flowchart of our process. In this process we have to take input image to further process of such as pre-processing, feature extraction, morphological operation to the face detection. This is the face detection is the final process of the fuzzy logic system. In this fuzzy logic we have to handle the color space very accurately. The color spaces, a wide variety of color spaces have been applied to the problem of skin detection. In the study RGB, normalized RGB, HSB and YCB RCR color spaces are analyzed and transformation in the spaces are performed. The RGB is very important to the feature extraction for pre-processing technique. The RGB components are dependent to the illumination conditions. For this reason, the skin detection with the RGB color space can be unsuccessful when the illumination conditions change. The defined boundaries of skin cluster is in RGB color space. The RGB is classified as skin if the following conditions are classified. The normalized RGB space is formed independently from varying the lighting levels. The red, green, blue components of normalized RGB space can be obtained from the three components of RGB space using the following formulations of like that. The RGB is equal to 1 formulation. That normalization is that it can be reduce the light effects. The HSB technique is to the hue, saturation and value space is also popular color space because it is based on human color perception. Similarly, the HSI color spaces is derived from the HSV. The intensity values, the lightness are related to the color. Illumination hue is generally related to the wavelength of the light. Then importantly we have to classify the system, so using the different color space of our process. This is the MATLAB main window. In that main window we have to concentrate on the four things: workspace, command history, command window and current folder. The current folder is nothing but the loading files of our executed files in our process. This is a command window. In this command window we have to view visually the executed of our source code. This is the workspace. The values and variables and the functions should be viewed using encoding should be in this part. This is the command history. In this command history we have to view what procedure is handled in our coding and executed in that command window. It should be stored in that command history. Now we have to run the coding in the current folder. Right click main.m, right click run. After the click run we have to showing the process of our fuzzy logic. I have to select the input, select this video, click open. Video is still loading. Please wait to the frame conversion. If your play video is give, I give one for playing that video. After giving one, the still is loading. process will be loaded for playing that video. The rendering the process to be initiation the extensions, the UI interface to be loaded, rendering the GUI of a process for playing the video. The dataset should be loaded. After loading the dataset, we have to play the movie player. The movie player should be stopped in that time. Whenever you click the play button, we have to play that video. After the playing that video, we have to hit enter the pre-process for the video in that command window. Please press enter. After pressing enter, we have to pre-process the frames each by each in our video. All frames should be loaded through the video, the JPG format. There are totally 80 frames to have to converted, and then RGB and OCC and HSP images should be loaded to the video to play the video. After the play and the video, we have to show the further process of our process, the red, green, blue and YCB and YCR, the hue, saturation and values. All images should be loaded in the video. The color transformation is perfectly viewed in that screen, the figure 2. Pretty. Please wait to evaluate the fuzzy process of our input value as a video. To evaluate the fuzzy process of for our input video, please wait the wait bar should be loaded for should be loaded for our process. Wow. இதே பாட்டு தான் என் சிஸ்டத்தில் இருக்கு என்கிட்ட. After the initializing the fuzzy process, we have to mask of red, blue and green transformation of our input video. The mask OIC and mask of CB and mask of CR videos to be viewed in that process. This is the hue, saturation, value video of our process. The mask should be viewed in that process. The face detection is perfectly done now for process to mask for our 80 frames of our video input video. This is the process of face detection using the color transformation of our process RGB, YCC and HSV values of our input video. Thank you.